Okay, so technically this is like part two, but obviously same day. So this is where we're starting. So thunderstorms, hails, and tornadoes. So again, these are all severe weather or catastrophic weather that we could experience up here in the Midwest. So we're gonna take a peek at it a little bit closer and see what are some things maybe we don't think of. We do prepare fairly well for these sorts of things, but not always. So still working with the same four standards. So middle school earth science standard 3-2, 2-5, 2-6, and 2-4. Basically, by the end of this, we should be able to interpret weather data to predict potential meteorological disasters, but I'm more so looking for you to be able to identify like mitigation strategies to help lessen the amount of casualties or damage due to one of these three or all three severe weather occurrences. So we have now moved down to the thunderstorms and hail and tornado portion of your notes. So let's get going. So in order to actually get a thunderstorm, there are a lot of certain things that have to happen. So we have to have three main ingredients: warm, moist air, rising air, and instability. So the warm, moist air, this is above freezing water typically, because if we have freezing water, we're getting snow. So above freezing, and this has to be very humid, thick air. So like when you step outside in the middle of summer and it's like you stepped back into your shower sort of feeling. So that is what I mean by moist, humid air. Rising air. So we have wind that's coming in and kind of thrusting this moist air upward. So creating this updraft and lift of the moisture into a much cooler region of our atmosphere. Um, we have to kind of think about it, and we'll dive more into this in our atmosphere portion of our meteorology unit, but the higher you go in altitude, or like the higher up into the sky you go, the cooler it gets. Now, the cooler it gets, the less water it can actually hold. So this is what starts to create our rain clouds and all of this. So if you have this updraft of warm, moist air and now it's getting cold, it starts to do what we call condensing into clouds and then potentially rain. Now that instability portion of all of this, this is where the atmosphere is just not able to hold on to all of that moisture anymore, and it starts to stack up. The rising air becomes unstoppable. It starts to fuel this storm. So the more moisture you're throwing up into this very cool, confined sort of area, the more likelihood of a thunderstorm to actually form. So that's kind of what's happening, especially if you look at this picture where you have this moist air down here getting thrown up into the atmosphere, and then you get these clouds that start piling on top of each other, and that's how we get our cumulonimbus clouds, which are our thunderstorm clouds. Okay, so there are multiple types of thunderstorms, and it really depends on where you are at within your thunderstorm season to kind of know how you're going to see. So there are three types. We have single cell thunderstorms, one massive cloud creating the storm. Okay. Multi-cell thunderstorms, a couple of them back to back, and a supercell. This is where you start getting the possibility of more severe weather. So single cell thunderstorms are just these like most common ones. They come in, they rain for like a half an hour, and then they move out. Okay. Those we see quite often up here, where it's kind of gross right away in the morning and then it clears out. So multi-cell thunderstorms are these cluster of thunderstorms that have just kind of, they got into line and they're just like, we're just going to keep going. These can last for several hours. These are super rainy days. You can get some wind, you can get some hail. The likelihood up here, though, not as much. And then we have supercell thunderstorms. These are the ones where everything else has just fallen into place to where you get that extreme wind, that extreme change in weather, to where we start getting the possibility of tornado production, as well as large hail and more damage. So These ones, like when you start hearing the like tornado warnings, this is what's happening. You have those supercells moving in and they're starting to rotate. You can see those big rotations on any weather map and things like that. Oh, excuse me. So those are the three different types. The single cell ones are like, oh, it rains in the middle of the day, and then we move on with our lives. Okay. Multicell is those long rainy days, and then supercell is like, oh goodness, we got some issues coming. So, lightning. Lightning is absolutely gorgeous, I think. Not a big fan of the thunder that comes afterward, but it's one of the most spectacular aspects of a thunderstorm. It's a giant electric spark caused by the separation of electrical charges within a storm cloud. It's Lightning McQueen, apparently. Mr. G put this slide together. So, now I lost like all drive for this. Way to go. So it's caused by a buildup of discharge of electricity within the thunderstorm. So a lot of positive and negative charges within a cloud. It's essentially all of these little atoms that are bumping into each other and just causing issues. Okay. So when the difference in charges become too great, two massive sparks jump through the air. Very similar to like you rub your feet on the carpet and then you go and you touch your wall outlet or something like that. Not outlet, light switch. Don't touch it. Wall outlet. Okay, things like that. Or you go and you boop like your mom's face or something, whatever. Okay. So it's just it's everything, the dust, the dirt, the moisture up in the air colliding together, creating this spark. Now, thunder, on the other hand, is the production after lightning. So it's the sound of the rapidly expanding air caused by the lightning. So the lightning comes down, that electric comes down, and then it like separates that air and then causes this thunder crack. Lightning heats the air around it to extremely high temperatures, causing it to expand, and then once it expands, it sends the shock wave of sound out, that's the air expanding, and that's how it comes to us as thunder. Okay? Now, thunderstorms, like we say, we live through this all the time during the summer, hopefully. I mean, we had a very dry summer last year, but some of the safety precautions that you take just naturally. Stay indoors as much as possible. There's no need to be going outside playing in the rain, especially once you start hearing and seeing lightning and thunder. That avoid open areas, tall trees, and bodies of water. Electricity really likes water, and water really likes to just force the electricity to go everywhere. So it's not a great combination. So all that kind of stuff. Tall trees obviously are working similarly to lightning rods, as it is the closest thing to the ground. So lightning sparks there, you're by the tree, lightning comes near you. Don't do it. Granted, Midwest, North Dakota especially, we don't have nearly as many large trees we have to be concerned with, but just something to be aware of. And then if you're in an open area, you are the lightning rod. You are the closest thing to the ground. So just be cautious. Number 3, this is probably one we don't think of very often, but do not use electrical appliances or telephones. When I say telephones, I mean if you still have the phone that is like attached to your kitchen wall, telephones. But electric appliances, you are the one who, like, the house is the closest to the ground for the lightning. Lightning hits the house. What is within the house? You have all these wires and electricity flowing. Your wires in your home are only expected to hold so much electricity, to where when there's too much coming in, it sparks off. That's why your lights flicker. That's why your clocks get reset, things like that. So if you are actively like If you're actively touching an appliance, I might have muted myself for a second. I forgot that it did that. But if you're actively touching an appliance and then you get this giant mass of electricity flowing through, it can then flow through you. Okay? I'm not 100% the person to talk about electricity with, but just don't do it. If you are caught outside, because it happens, sometimes storms just move in really fast, or you maybe didn't account for how quickly this storm was moving in and you're at the park. Just make sure that you take shelter under like a sturdy building. Try to get to like an actual awning. Don't go under the metal playgrounds, things like that. That's also not safe. So just stay there, hunker down for a little bit. Typically, again, up here, our storms move through fairly quickly, and they don't usually get to like a catastrophic sort of moment. So, safety during thunderstorms. Okay, again, things that we already kind of think of. Hail. Hail is so cool to kind of like figure out how does this happen. So it's such a simple weather phenomena. We get hail now and then, and it's usually just the itty bitty stuff that doesn't really cause issues. But as soon as it starts getting larger, we have concerns for property. We have concerns for vegetation. We have concerns for our own noggins. Okay, so let's talk about hail. Okay, so we already started kind of talking about updrafts because that is what creates our thunderstorms. So again, our updrafts are just that wind that kind of forces this warm, moist air up into our atmosphere. So when we already have a thunderstorm going and an updraft within it carries water droplets to the highest portion of our altitude, what happens is that it's so cold up there that the water droplets actually begin to freeze. Because as hail is, it's just frozen water. It's ice. So it gets pushed up into those freezing temperatures and turns into ice. Eventually, the ice gets too heavy and it wants to fall down, where it then starts to collide with some more water droplets, other ice particles, and they start to kind of stick together and grow just slightly larger. Okay, now if we have strong enough updrafts, this process can happen a couple of times, and every time it starts falling down, it gets bigger and bigger and bigger. You have to think of like a jawbreaker. You're just adding more layers to it until it does become too heavy for however strong the updraft is, to where then it falls to the ground as a hailstone. Most of the time for us, the updrafts aren't strong enough to where we get just little itty bitty like pea-size sort of hailstones. But I remember like when I was a kid out in Colorado, granted you have the mountains, so you get a whole different sort of like wind experience. Their updrafts were so large, you were getting like baseball-sized hail. It's amazing, but also like terrifying. Like amazing thinking about it now as an adult who enjoys learning about weather. Terrifying as the 10-year-old with skylights above you. So essentially this is what is happening within your cloud. So you have that cumulonimbus cloud or that storm cloud. You get this updraft of air where you have all these water droplets and it's getting forced up above the freezing line. It only has to be 32 degrees Fahrenheit or 0 degrees Celsius in order to start freezing. So it gets thrown up there, starts to freeze, and then it goes through this convection essentially, but because of mass, not necessarily because it gets too wet or it gets too cold, but yeah, kind of like that. Okay, so it gets cold, freezes, it gets too heavy, so it starts to fall down. But if you have another updraft coming up, then it goes and it throws it back up a couple more times until it becomes too heavy and it can actually fall down with the downdraft. That is how we get the obnoxious sized hail that we can receive. So there are technically 4 categories of hail. We have small, medium, large, and giant. So our small hail is going to be less than 1/4 of an inch or about a pea size in diameter. Usually this causes little to no damage. Okay, they fall, you see them, you might hear them on the ground, cool, fine, whatever. If it's hitting up against your window, you'll just hear like clicks, like little like sand pieces. It's not a big deal. Medium-sized hail, however, this is 1/4 of an inch to 1/2 an inch. I don't know why I went this big. It means it's more so like a walnut size. I hate like the idea of, and I don't, why would I have a ruler in here? That would just make sense. Okay. But these are a little bit larger. We're talking maybe a little bit smaller than a marble, but these can start to damage cars and hurt vegetation. If you have pretty little flowers around your home or whatever, like those are the vegetation that's going to get hurt because they weren't necessarily like developed to be strong against hail. Okay, so medium hail is where we start to see the damage. Okay, you might get little pings on your vehicle because aluminum's not that strong, and you think of how far it's falling to the ground, it gains some speed. Okay, large hail. This is 1/2 an inch to an inch, so golf ball to baseball size. Okay, golf balls are like this big. Baseballs are bigger. Okay, this is issue. This is a big issue. So can cause significant damages to roofs. So you're hitting these asphalt shingles. It can break those apart really easily. All that, you're causing significant damage to cars. I mean, think about like you see the videos of like someone throwing a baseball and hitting a car window, how that shatters. Now imagine a couple hundred of those coming down. Okay, and then this is where we start to see damage to crops. Corn and wheat, soybeans, everything we grow up here has been bred and developed to withstand our significant winds and some of our weather. To where hopefully we're not seeing a loss in crop because one hailstorm moves through. But as soon as we start getting into that large hail size, nothing can stop it. Okay, now we're talking about giant hail. So anything that's bigger than an inch in diameter. This is huge. So these are your softball sizes. They're very, very rare, but incredibly destructive. You have the possibility to cause severe damage to buildings, vehicles, inflict injury on peoples and animals who are caught out there. Again, think about like a baseball coming and like you're trying to catch a pop-up and it hits you right in the forehead instead. Okay, now imagine that a couple hundred times and falling from a much greater height to where it has more velocity behind it. It's not good. Here's a picture, and it's an, oh, that is a Colorado plate. So go figure. This is what could happen. Damage to your property. It is ridiculous what hail can do when it gets to large enough sizes. You get hail that can damage roofs, siding, windows, cars. Your car ends up looking like this. Okay, you have a busted up windshield, you have busted up body, and all of that kind of stuff. God forbid you have a moonroof or a sunroof, it's toast. Okay. Damage to crops. Like I said, hail can start to destroy some crops, leading to agricultural losses, and especially up here where we have a lot of farming families who depend on the produce that is produced by end of season. Okay, so kind of a big deal. Injuries to peoples and animals. Again, you don't want giant rocks or softballs or baseballs hitting you in the noggin. You only have one. So it can cause a lot of damage to your brain. Okay, when it starts to hail, if there's hail, you need to avoid driving. Okay, just because again, this is what can happen to your windshield. And if you can't see out of your windshield, we now then have more issues. Okay, take shelter. You for sure need something over your head. Okay, and then avoid windows. If our winds pick up, like it can easily throw some hail through a window, which again, not good because now on top of having ice balls coming and trying to hit you in the head, now you also have shattered glass being thrown around. Perfect storm for not fun things. So yeah, hail, really, really cool to think about how it happens, but also terrifying in the midst of it. Tornadoes. So probably our biggest concern comes spring and sometimes in the fall, is the possible production of tornadoes. I am recording this on Sunday. Now it's gonna test me. What day is it? March 16th. We just had a massive low pressure front move through the Midwest, and we went from 60 degrees, 65 degrees. I remember on Thursday or Friday I was walking around in a short sleeve shirt. And then on Saturday I wore my winter coat and we had ice on our windows and all of this. So when something big like that moves in, it causes the perfect condition for tornadoes. And that is what some of our more southern Midwest states experienced, where there was 15 plus tornado touchdowns throughout the lower Midwest just on Friday into Saturday. So we're going to talk about why all of this happens, but like it's something to be concerned with. Now, granted, we are at the uppermost limit of Tornado Alley to where we maybe get 1 or 2 tornado warnings a season. I mean, we have, living in Horace and West Fargo, we experience our tornado systems like going off all the time. I know when it's 6 o'clock and 9 o'clock each evening because I hear the sirens going. Just as a little like, hey, make sure you recognize us. It was like noon the first Wednesday of each month. I would hear it at school. Now that I have an interior room, not so much, but that's what's going on. So tornadoes, nature's fury. So what is a tornado? Let's start with what it is before we talk about the differences in tornadoes. So it is a violent rotating column of air that extends from the storm cloud to the ground. Okay, storm clouds live fairly high above us. Okay, you have a good couple of kilometers between you and it. But with those updrafts and this like spinning motion that can start to happen, we have the possibility for tornadoes. So the rotating air starts to form this funnel-shaped cloud that is visible because it's condensed. You see the cloud literally starting to come down and make ground contact. Tornadoes can very much vary in size, in strength, and then its path lengths. Some tornadoes only last maybe a couple miles. Some of them last quite a few. So those are just a couple, like that's what it is if we were to break it down. Now the types of tornadoes, it kind of depends on where it is forming and all the other perfect ingredients going on around it. But there are 4 main ones that we should talk about. So the water spout, this is where a tornado forms over a body of water. This can sometimes happen over lakes. So you get like this tornado plus like a whirlpool sort of effect. It's like all the worst ways you can die, in my opinion. That we have multi-vortex tornadoes. This is super duper rare, but you get 2 or more funnel clouds rotating in a common center, and then you got a couple of tornadoes hanging out. That land spouts are weak, short-lived tornadoes that form over land and often associated with like non-severe thunderstorms. So these are the ones that kind of come out of nowhere. We don't see them very often. What we typically see is the classic cone tornado. And this is the most common form of tornado where the funnel shape extends from that thunderstorm cloud down to the ground. This is what we see, but like we can tell when it's kind of sort of starting to emerge and where we might have those issues and all that kind of stuff. So those are the different types of tornadoes. Now, granted, there are many, many more. We have a record now of a lava tornado where a tornado formed over the Kilauea volcano summit just a couple of weeks ago in Hawaii. Like, that's terrifying. But yeah, there's different types, but these are the ones that we may experience up here in this region. So this is a video. I love this guy from the Weather Channel. He explains it so well. I want you to take a moment, pause me, go to him, and then come back. But he walks you through like the 3D visualization of like what a tornado does, how it moves from something we're able to look at and predict into the actual like thing. So pause me for a second, come back in a moment, watch this guy and see what's going on. Okay, so just like we have a scale for earthquakes and all of like that sort of stuff, so the Richter scale for earthquakes, we do have a scale for tornadoes. We have the Fujita or the EF scale of tornadoes. So the Fujita EF scale is used to classify tornadoes based off of the amount of damage that they cause. Okay, we have from 0 to 5. So 0 would be like the weakest sort of a thing, 5 being the strongest. Winds tend to increase during this time to where this is how we kind of define it as far as like the amount of damage that could happen. Because yes, fortunately, sometimes we have tornadoes that only form over like open fields where you're not going to get a lot of actual damage to structures. But unfortunately, they can rip through towns. So the EF0 range is the weakest category where you have winds only, I say only, very loosely, reaching up to about 73 miles per hour. This tends to form like minor damage, some siding, things like that, all the way up to EF5, which is the strongest category with winds exceeding like hundreds of miles. Okay, so that's kind of what's going on with that. It's not changing. There we go. Okay, so tornado warning versus tornado watch. This is like the best example I can. This is the only way I ever remember it. Because we talk about, oh, we're in a tornado warning, we're in a tornado watch. At what point in time do we say, hey, there's a tornado, get down to the basement, sort of a thing? Well, tornado watch is like, hey, watch out. I'm about to make me some tacos. Okay, I have all the ingredients. I'm ready to go. Versus a tornado warning is like, whoa, we're having tacos right now. Okay, warning, I'm about to consume all these and it's not going to end well. Things like that. That's essentially what a watch and a warning comes down to. So a tornado watch is like we see all the ingredients starting to add up on our weather monitoring data. We see, okay, we have the winds, we have the moisture, we have the like weird air movements, things like that. We don't have a tornado, but we have everything that makes a tornado. And then the tornado warning is, ooh, we have a tornado. Now it's really like game time. So it's vital to understand the difference between the tornado watch and the tornado warning issued by, typically it's going to be the National Weather Service. The tornado watch indicates that the conditions are favorable, that we got a lot of things like they could start predicting the possibility of tornadoes back Friday, like early afternoon, even though that low pressure system didn't really go through until like Friday evening. We're like, hey, we see everything that could add up to something really bad. So this is the time where you're going to want to be very vigilant, staying informed with your weather updates and things like that. A tornado warning signifies that there has been a tornado actually spotted. Like a funnel cloud has actually been created, whether it has made like landfall yet or not, that is variable depending on the region you're at. But it's saying, hey, we now have a tornado, so you need to take the necessary precautions to keep yourself and others safe. Okay, so that is the difference between a tornado warning and a tornado watch. So tornado safety, before a tornado even happens, again, there's usually some sort of community warning system and have a plan as to where you need to take shelter. Okay, we do it all the time in the schools. Okay, we say, hey, we're gonna have a tornado drill, and most of the time people like pile into our science labs because we're in an interior classroom or they're in the hallways away from all the windows and FTLAs and all this or whatnot. So great, we know what to do. At home, you might have like a tornado safety kit, including some food, water, first aid supplies, battery powered radios, maybe not that exactly, but you have like your phones with data and they're charged and ready to go, and flashlights. And you typically have it stored in a safe place in your home where you might be going if there is a tornado warning out there. Okay? During the tornado, the best place for you is going to be inside in the lowest level portion of your building, preferably an interior room and away from windows. So like our basement's unfinished. We go underneath our stairs. We have little mats or whatever, so at least we're sitting on something cozy. And all that. We used to keep like backup supplies for Will down there. Who knows? But it's wherever you and your family have deemed the safest place in your home. Now, for my apartment livers, just getting down to the first floor and hanging out in that main like stretch of hallway is actually really safe. But making sure that you are covering your head and things like that. If you're in a mobile home, getting to probably the most interior portion of this home is going to be the best. If you can get under a sturdy piece of furniture, heavy table, workbench, things like that, that's good too, because then you have more protection from things falling down. But make sure you're covering your head and your neck, and all this. The other thing that we don't talk a lot about is making sure that you have shoes on. Or having shoes in that safe place, because it's not so much the getting to the safe place that like I'm concerned about your feet being covered, but it's after the tornado has moved through and now you have all of this like broken debris and everything around. You don't want to get splinters or step on nails or things like that. So make sure that you have shoes in your safe space, so that if you happen to be caught outside and there is a tornado warning, you need to lie as flat as you can within a ditch or a low-lying area and cover your heads with your hands. Tornadoes very much kind of follow a very linear path to where it's not going to go up and down a lot, because that's how it loses more of its momentum and energy. So if you get to just a really low space, you should be pretty good. Now, don't quote me, okay? After the tornado, once the winds have died down, everything's quiet again, you need to make sure that you check for injuries. The likelihood that if you are in the middle of a tornado that you don't walk away with something is less likely. And make sure you call 911 if necessary. Stay away from downed power lines, and other sort of electric things, and then be aware of possible flash flooding. Probably not a super huge concern unless you live directly on the river, but typically if there's enough energy to create a tornado, you probably had quite a bit of excess moisture and things like that, to where some areas could be a little flooded. Okay, so those are all the safety sorts of concerns that we need to be worried about when we talk tornadoes. So that kind of wraps up like our concerns in the Midwest. Now let's move a little further south.